Greg, who you met down the pub, may say he's got a great load of wood for you.
How do they actually compare environmentally?
That's obviously a very big opening. But when we're sort of head to head with a oil or gas boiler, stoves aren't doing too bad.
Right, now let's tackle questions about efficiency, cost, and environmental impact. How do log burners compare to other heating options regarding efficiency and running cost?
Modern stoves are really quite efficient, but also fuel has a really big effect on the efficiency of any appliance. So a modern stove will be up into the 80s in terms of efficiency. A pellet appliance be up into about the 90s. But then fuel is also having that big effect. So if you've got damp logs that you're trying to burn compared to a sawdust briquette, say, that's going to have a bigger effect on the efficiency than spending out an extra £500 on a stove that claims to be 10% more efficient. So fuel is really, really important as well. In terms of how a stove compares to other heating appliances, so you've got gas boilers, which in theory get to your 95% efficiencies, but that really is determined by the heating system they're connected to. So often they'll be running at something into the 80s, similar to the stove. And then, of course, heat pumps have huge efficiencies. Technically, it's not called an efficiency, but you're putting 1 kilowatt of electricity in to get 3-4 kilowatts of heat out. So with the direct heating appliance like a stove or a gas boiler, we're never going to approach a heat pump's efficiency. But when we're sort of head to head with a oil or gas boiler, stoves aren't doing too bad.
So we've touched on the kind of environmental benefits already of log burners, but how do they actually compare to other heating sources? So, if you are burning wood in your wood burner versus, the gas that's coming out of the fumes that are coming out of your gas flue, how do they actually compare environmentally?
In terms of particulate emissions, the wood stove will be higher than the gas boiler. It's a less controlled combustion, and that gas was created millions of years ago and has kind of been more purified as a process underground. In terms of carbon dioxide and methane emissions, however, the gas isn't doing very well, because in gas extraction, a lot of methane, both documented and undocumented, is released, which has a high global warming potential. And of course, then there's the CO2 being released, which for gas isn't taken back out of the atmosphere. And for wood, you've got a cycle of harvesting of that wood, the use of it, and the release of the carbon dioxide, but then another tree being planted, growing back up again, reabsorbing that. In addition, wood has wider uses, so we can build out of it, we can insulate things with it, we can do all sorts of things with wood. And so, for example, some places may use timber offcuts and sawdust waste, for example, to make fuel out of, or you may have the smaller branches from a woodland going in to make fuel, and the bigger sectional timbers going to be built with, that sort of thing. And then you've got the smaller type suppliers who are maybe in the hundreds of tons a year, where they're managing their own bit of woodland locally, taking a few trees out at a time, chopping that up and seizing it themselves, and then selling it as part of the local economy, which of course you don't get that with gas. You have to be quite a big organization to harvest and process gas.
So what is your opinion on heating with firewood versus biomass briquettes, so things like wood, bark, coffee, rice husks, etc.?
So it depends on your situation, really, I think. So some people that come to us have their own bit of woodland, and they want to heat their whole house with that wood that they're managing themselves. And so that's an ideal situation. You've got the wood at hand. It keeps you fit by harvesting it and processing it. That's ideal. Other people may have to buy their wood in, and then it depends where they're getting it from and how reliable that source is. Greg, who you met down the pub, may say he's got a great load of wood for you and it's brilliant, honest. But when it turns up, it may be actually really wet. And so whilst Greg's wood appeared really cheap, actually you're not getting any heat out of it. So per kilowatt hour, it's really expensive. Plus, it'll give you a whole load of maintenance issues for your stove and your chimney. So that's a cost in either money or time. Whereas some kiln-dried wood or a briquette is a known thing. You know how dry that's going to be. It's guaranteed. You know how much heat that's going to give out. So it depends on who you're getting that local wood from. There's good suppliers. There's bad suppliers. And then whether you want the surety of absolutely knowing that wood is, or the fuel is definitely dry, then you might go for kiln dried or sawdust.
So what are the main differences between traditional log burners from, let's say, 20 years ago and a modern model that you can actually buy today?
A really big difference is they're good at being turned down and staying efficient. So when you turn it down, you'll still have a good flame pattern. And it won't all soot up inside. Your window will stay comparatively clear. That's a really good sign, in fact. So when you're using the stove, you're looking for nice flames without black bits at the top. The black bits is unburnt fuel, and that means you're not getting value for money out of using that fuel, plus you're releasing more particulate emissions. So that's what you're trying to avoid. And you can do that by controlling the air intelligently. So when you first light the stove or when you refuel the stove, you'll have an air supply that goes to the bottom of the firebox. And you can think about that as the boost supply. So you boost the stove when you're first lighting it or when you're refueling it. Then you'll often have a secondary air control, which supplies air to either the top of the firebox or sometimes to jets that come out of the back of the stove. Often you can see the effect of that air as the wood gas combusts around the air as it goes into the firebox. So you'll use that control once the wood's going well and the firebox is warm. You'd shut down the primary air and you'd control using that secondary or tertiary air supply. So both of those things are going to keep those gases burning really well and completely, even when you shut the stove down more. So that's one of the advances that stoves have made. Fire bricks have often become more insulating, so they often tend to be vermiculite now, a bit more of an insulating material than a solid cast fire brick. So that firebox temperature can likely rise a bit faster. The stove can be a little bit more nimble. Stoves also often have a direct air supply connection on them now, so that when a stove burns, if you open the door of the stove to refuel it, that's obviously a very big opening, and so air rushes up that chimney. It might be 25 litres a second of air, so it's a lot of air. Whereas if you shut the door, then the size of the air intake is, the size of a coin. It doesn't need a lot of air. So for supplying that air, there's often a connection on the back of the stove, and you run a duct outside. And so when it's running with the door shut, it's not creating any draft in the room and just drawing air straight into itself. However, it is something you need to think about, is when you open the door of that stove, is there enough air coming into the room to supply that air so that it can go up the chimney? Compared to 20 years ago, we now have wood pellet stoves. So automated, they light themselves, turn themselves off, regulate themselves, clean themselves. And we didn't have that 20 years ago. But as I was saying earlier, to replace a normal stove in a room without there being a boiler around it, that hadn't been a particularly pop choice at that time.
Can you please explain the clearSkies certification program and how it can help someone make a more informed decision?
So clearSkies is a scheme that the SIA, so the Stove Industry Alliance, have come up with to try and go over and above the eco-design legislation, which the EU and the UK have adopted. And they rate stoves depending on, one of the points is whether it's DEFRA exempt or not. and then they rate them again according to efficiency, particulate emissions, OGC, and NOx, and give them a star rating to actually compare them against each other. So manufacturers or importers who've joined that scheme will have star ratings for different stoves, so you can then go and compare them against each other and see which one is better. So it's a bit like the ratings you might see on a washing machine or something like that.